These are the practice problems for lesson 10, calculating slope. And for problem number 1, there are 3 parts. Each of the parts has the graph of a line, and you are supposed to find the slope of that line. You're supposed to calculate the slope of that line. So in part A, there's point A and there's point B. Point A is at 8 units along the x-axis, 4 units along the y-axis, and point B is at 2 units along the x-axis and 6 units along the y-axis. And I'm going to treat this or look at this as if I'm moving from point A to point B. So what that means then, if I'm moving from A to B, then I'm going to take point B, the x-coordinate and the y-coordinate, and I'm going to subtract the coordinates for point A. So I'm going to take this away, so this is going to disappear, and you're going to be left with this length right here. So in the first case, you take the y-coordinates, that's this 6 minus this 4. And I'm going to show you the slope triangle in a moment, but what I'm doing right now is I'm taking away these 4 units right here. I'm sliding this whole thing down 4 units. That's the 6 minus 4. And that's the y-coordinates. And the x-coordinates are this 2 minus 8. So I'm going to slide this down 4 units. That's the minus 4. I'm going to slide this over 8 units. That's the minus 8. So you have 6 minus 4 is the change in the y, the vertical direction, or it's the length along the vertical axis, and 2 minus 8 is the length along the horizontal axis. Well, the vertical axis then becomes 2 units. That's a positive 2 units, and the length along the horizontal axis becomes a negative 6 units. And you can factor out the 2's from that, so it's 2 times 1 and 2 times 3, and so that answer becomes a negative 1/3. And a little reminder of how to make this calculation right here, because this is a larger positive value that you're subtracting from a smaller positive value. So you can view that as subtracting a positive 8. So then you can change that subtraction to addition. So it's the inverse operation of subtraction, which is addition. And then you're going to use the additive inverse of a positive 8, which is negative 8. And you find the difference between 8 things and 2 things. That's 8 minus 2. You're left with 6 things. But those 6 things are negative because you have more negatives than positives. So this is a negative 6. And so that makes this slope equal to negative 1/3. Now, using the slope triangle, I've also realized that it's useful to not only look at A moving to the origin, so we're going to move A to the origin like this, but it's also useful to think about what's happening to this horizontal side of the slope triangle. This side, this horizontal side of the slope triangle is moving to the x-axis. And then it's going to slide along the x-axis until A is at the origin. So you slide it down 4 units. That's this 6 minus 4. So this 6 right here, these 6 units. I'm going to subtract these 4 units. So this point is going to slide down to here, and A is going to slide down to the x-axis. And then you're going to slide A over to the origin, which is going to slide these, this point, point B, 8 units in this direction. So where is that going to end up? That's 2 minus 8 along the x-axis. So it's this 2 right here minus this 8, 2 minus 8. So it's going to end up at negative 6 units out here. So this side right here is going to slide over 8 units, and it's going to end up at a negative 6. So notice what happens is that because this ends up out here at negative 6, this length is a negative 6 units. So this is a negative 6 units, and this length we already saw is a positive 2 units. So this is negative 6, this is positive 2, and so that slope is positive 2 over negative 6, which is right here, this positive 2 over negative 6, and that factors out to be a negative 1/3. Now if you're going to write the equation for this line in the form of y equals mx plus b, you're going to start with calculating the y value or this distance along the y-axis right here as y minus 4. So that's this y minus this 4, or this y right here minus that 4. So y minus 4, and that is over x minus 8. So it's the same as right here, but it's y minus 4 over x minus 8, and that's equal to a negative 1/3, which is a positive 2 over a negative 6. Now I'm not going to go through that, but I'll leave it up to you guys to go through how you get this in the form of y equals mx plus b. You're going to multiply by x minus 8, and then you're going to add 4 to both sides, and you should end up with y equals a negative 1/3 x plus what? Where does this cross the y-axis? And you figure that out when you figure out the equation. All right, part B. So I'm going to start with the slope triangle, and I'm going to move that, and then I'm going to write mathematically what's going on as we make that move. So this is the slope triangle. And again, I'm going to treat this, this is interesting. So what am I looking at now? So I'm slid it down to here, and then I slid it over to here. So I'm sliding this point and this horizontal side of the slope triangle down to the x-axis, and this point down to the x-axis. So I'm subtracting this point from the coordinates for this point from the coordinates for this point. So this is going to be 1 minus 7 and 1 minus a negative 5. So 1 minus 7 moves this point down here, and 1 minus a negative 5 is the same as 1 plus 5. So that slides us over in this direction. So let's see if that's what it ends up showing you. So this is taking away 7 units, so minus 7, and this is adding 5 units, so plus 5 to get to here. So I'm showing this as moving from A to B, so I'm going to take the coordinates at B and subtract the coordinates at A. So moving from A to B, so I'm going to subtract the coordinates at A from the coordinates of B. So this is going to be the y coordinates are 1 and positive 7, so it's going to be 1 minus 7. So 1 minus 7 is this, subtracting these 7 units right here, and it's this 1 minus these 7 units. So this slides all the way down here so that this is along the x-axis, and then it is this one in the horizontal direction minus, or actually minus a negative 5 means that it's 1 plus 5. So now you're going to slide this over 5 units. So the slope triangle is going to end up down here. So 1 minus 7 is the same as 1 plus a negative 7. So again, this is 1 minus a positive 7. So you can use the inverse operation of addition and use the additive inverse of negative 7. And this is 1, and use the inverse operation of addition and the additive inverse of a positive 5. So you get 1 plus a negative 7 and 1 plus a positive 5. Well, 7 minus 1 is 6, but it's a negative 6. And then 5 plus 1 is a positive 6. So this slope ends up being a negative 1. You can factor out the 6's, and you're left with a negative 1 over 1, which is equal to negative 1. So to figure out the equation that goes with this, notice that you end up here with a positive 6. That's this 1 minus 7. I'm sorry, that's this 1 plus positive 5. Slide this over, this ends up being a positive 6, and this is a negative 6. So this is, here's the y value as negative 6, and the x value is positive 6. So it's this negative 6 over this positive 6 as you move this way 6 units, and this way a negative 6 units. And to write the equation, just replace the 1 and negative replace the the coordinates for 1, or the coordinates for b, the 1 and positive 1, with y and x. So it's y minus 7. So it's this y minus this 7, and it's x plus 5. Remember that, so it's this x right here plus 5, which is really x minus a negative 5. So this is x minus a negative 5, which is x plus 5, and that works out to equal this slope. So again, I'm going to leave it to you to figure out how you get this in the form of y equals mx plus b. And the last problem, so I'm going to draw both slope triangles. Hopefully this makes it a little bit clearer what's going on. So you could choose. You can slide this slope triangle up to here. So that's sliding this horizontal side to the x-axis here. So you're going to slide this point up to the x-axis and then over to 0, 0. So this is going to be the pink slope triangle, which is going to go right here. And the blue slope triangle, you're going to slide this point up to the horizontal axis because this is the horizontal side. So this is going to go all the way up here. So you're going to add eight units to get this to move all the way up here. And then you're going to slide this over just 2 units to move this over to here. So this blue triangle is going to go way up here and end up here, and the pink triangle is going to go over here and down like that. So this is the blue triangle, which is this point sliding to the origin, and this is the pink triangle, which is this point right here sliding to the origin. And what I'm really focused on right now is what's happening to the horizontal side of each of these slope triangles. And in each case, that is going to the x-axis. So this side is going up to the x-axis and then sliding over. This side is going up to the x-axis and then sliding over just a couple of units to here. All right, so this triangle up here is -3 minus a -8. So it's this -3. So we're going to take away these coordinates, the x coordinate and the y coordinate of b right here. So we're going to slide this up 8 units, which is the same as -3 minus a -8, which becomes -3 plus 8. We're going to slide this over 2 units. So this is going to be a -6 minus a -2, or a -6 plus 2, or -8 minus -3. Or we're going to look at this pink triangle by sliding this point up -3 units. So that's adding 3 units. So -8 minus -3 is a -8 plus 3. And then adding 6 units. So subtracting -6 is the same thing as adding 6. So it's going to take a while to get used to that. So both of these work out to be, you can change both of these to addition, subtracting a negative. You can use the inverse operation and the additive inverse in each case. So it turns into adding the additive inverse, adding the additive inverses. To figure that out, you find the difference of the number of things you have. So 8 minus 3 is 5, but this is positive 5 because there's more positives. 6 minus 2 is 4, but it's -4 because there's more negatives. And likewise down here, it's 5 negatives because 8 minus 3 is 5, but more negatives. And 6 minus 2 is 4, positive 4 because there's more positives. So this is -5/4, and this is -5/4. They have to have the same slope because it's the same line. All right, so if I took all of that away and took all the writing here away and just wrote the beginnings of the equation. So this is y minus -8. So this is y right here minus this -8 over x, which is right here, minus -2. So that's going to be y plus 8 over x plus 2 equals that -5/4. Or y minus -3. So this y right here minus -3 over x, this x right here, minus -2. And so you get y plus 3 over x plus 6 equals -5/4. So look at how this is really very similar, and it has to be. It really comes from the same place as what we wrote up here with the numbers. Now we're just writing it with the x's and the y's to figure out the equation. If you work through this, you're going to end up with y equals mx, or negative 5/4 x. So this is the m part of the equation, the slope, plus, and where does it cross the x-axis? It crosses the x-axis way down here at a negative 10 1/2. So negative 10 1/2. Now I'm going to leave it up to you once again you should work with this form of the equation right here and get it to this form. And then likewise, you should work with this form up here and get it to the same form. And I'm giving you the answer, which is right here. So if you start out with what's in blue, this is the blue for the blue slope triangle. It's this part up here. And then what's in pink, this is the pink slope triangle. So this is this part right here. And you work through, you end up at the same place. Y equals a negative 5/4 x plus a negative 42/4. One of the tricky parts is to realize that 8 is the same as 32/4, and 3 is the same as 12/4. Other than that, everything else I think you can work through fairly well. And you end up in the same place. So from this point to the end, it's the same for both equations. So I'll leave this here for you to check your work as you work through this equation right here and this equation right here to get to this final form right here. Okay, this is problem number 2, and in this case there are 5 pairs of points and 4 slopes, and you're supposed to match each pair with its slope, which is shown on the right here. So there's 4 slopes, 5 pairs of points. So 2 of these are going to have the same slope. And I'm going to treat this as if you're moving from point B to point A, which means this is the start, this is the end. So I'm going to subtract the beginning part away from the ending part. So this is going to turn out to be a calculation of A, the coordinates at A minus the coordinates at B. And so this is really just practice of just setting up, calculating the slope, and then going through that calculation. So this is the number of units that change along the y-axis is 10 minus 2. So what's the length along the y-axis? It's that 10 units minus these 2 units, which equals 8. And that is over the length along the x-axis. So that is these 7 units subtracted from these 9 units. So that's 9 minus 7. So that's 9 minus 7. And 9 minus 7 is a positive 2. And so you end up with the number of units in the vertical direction are 8 units for every 2 units in the horizontal direction. So that simplifies to 4 units in the vertical direction for every unit in the horizontal direction. So the vertical direction, the length along the vertical axis, is 4 times the length along the horizontal axis. So that gives you a slope of 4. So that's number 1 right here. The second one is negative 11 minus negative 5. Negative 11 minus negative 5, which is actually adding 5. We'll go through that in a moment. And a negative 8 minus negative 1. So these are the length along the y-axis is the change of these y coordinates. So negative 11 minus negative 5. And that works out to be a change of negative 6 units. Along the x-axis, it's negative 8 minus negative 1, which turns out to be negative 8 plus 1. So you find the difference of these. They have opposite signs. So 11 minus 5 is 6, but it's going to be negative because there's more negatives. And 8 minus 1 is 7. It's also going to be negative because there's more negatives. And a negative value divided by a negative value gives you a positive answer. So this is 6, 7. So what this is saying is that the length along the vertical axis is 6/7 the length along the horizontal axis. So it's not quite as long. It's 1/7 of the length along the x-axis shorter along the y-axis. So this is the answer right here. Number 4 is 6 sevenths. The C is the length along the vertical axis is a negative 6 minus 3. So negative 6 minus 3. Length along the x-axis is 5 minus 2. 5 minus 2. That length's a little bit easier to calculate. It's just 3 units. But the length along the vertical axis is a negative 9 units. So every 3 units you go along the x-axis, you're going to go down 9 units in this case. So it's a negative 9. How do you get negative 9? It's a negative 6 plus negative 3. So I'll leave that up to you to go through, reminding yourself how to do that calculation. You can factor out the 3's. You're left with negative 3 over 1, which is a negative 3. So this is answer 2 right here. So negative 3, this is 2. The next one is the y value minus the this y value 3 minus this y value negative 1. So that's in effect adding a positive 1. Inverse operation, additive inverse, 3 plus 1 is 4, and 6 minus 5 is 1. So again, for every 1 unit in the horizontal direction, you're going to go 4 units in the vertical direction. So this is a slope of 4. So this is the second one, which has a slope of 4, which is this number 1 up here. And the last one is this y value is 7 minus this y value is 2. So it's 5 units. And this x value is 4 minus this x value, which is 6. 4 minus 6, same as 4 plus a negative 6. 6 minus 4 is 2, but it's going to be negative 2 because there are going to be more negatives. So this is a negative 5 halves. And so what this is saying is for every 2 units in the horizontal direction, you're going to go down 5 units in the vertical direction. Or if you go in negative 2 units, this right here, go in negative 2 units in the horizontal direction, you're going to go up 5 units in the vertical direction. So that would be this negative 2 and positive 5. And that is number 3 right here. So this is a negative 5 halves. All right, some practice just calculating slope. For problem number 3, they give you all these points on a grid, and you're supposed to draw a line with the given slope. So here are the given slopes right here, and here's the starting point right here. Through the given point, what other point lies on that line? So you're going to find a second point that's on that same line. So for A, start out at point A, and this has a slope of negative 3. Well, slope of negative 3 means that for every unit along the x-axis, so for every positive 1 unit, you're going to go down negative 3 along the y-axis. So it's 1, negative 3, 1, negative 3. Or if you go, actually I drew it as a negative 3 first and then a positive 1. So for every 1 unit along the x-axis, it's a negative 3 units. And it might make more sense to you to say for every 1 unit along the x-axis, it's a negative 3 units. So 1 unit, negative 3, 1 unit, negative 3. And the other point that's on that same line is B. You can look at it either way. Look at the y, change in y first as negative 3, and then a positive 1. But it's really, what you're actually doing is saying for every single unit, I'm going to go down 3 units along the y-axis. So it's actually better to look at it as positive 1, negative 3, positive 1, negative 3. All right, the next one is B. So it starts out at point A also, but now this has a slope of a negative 1 over 4. So it's actually telling you, treat the change in y as negative 1 and the change in x. So the length along the y-axis is negative 1. The length along the x-axis is 4 units. So you can read this as every 4 units, 1, 2, 3, 4, goes down 1 unit. So this is 4, negative 1, or goes down 1 unit, that's a negative 1, and then 4 units along the x-axis. So either way, so this is negative 1, positive 4, or so for every 4 units, positive 4, negative 1. And the second point that's on that same line is point D. So right here, point D. And for C, C starts out at point C. So here's point C over here, and it's a slope of -1/2. So the change in the y direction is -1 unit for every 2 units in the horizontal direction. Or you can say for every 2 units in the horizontal direction, there's a change of -1 in the vertical direction. And I still think it's better to start out with the horizontal direction and then look at the vertical direction. So for every 2 units, it's a change of -1. 2 units, a change of -1. 2 units, a change of -1. And the other point that's on that same line is point E. And the last one starts out at point E and has a slope of a -2/3. So for every 3 units along the x-axis is a change of -2 along the y-axis. So 3 units, -2, 3 units, -2, or you can do the y-axis first. So you go down -2 units, and you're going to go over 3 units. So down -2 units, over 3 units along the x-axis, or for every +3 units, it's a change of a -2 units along the y-axis. And point B is on that line also. So change of 3 units, 1, 2, 3, and then for every 3 units along the x-axis, it's a -2 units along the y-axis. So it's going to go down 2 units. All right, this is problem number 3. In this last problem, problem number 4, it says to make a sketch of a linear relationship, so draw a line with a slope of 4 and a negative y-intercept. Show how you know the slope is 4 and write an equation for that line. So the first thing I did is made a few notes about what the slope of 4 means, and that is the length along the vertical axis. So this is +4 divided by the length along the horizontal axis. So this is +1. So the way you calculate that is the change in y along the vertical axis divided by the change in x along the horizontal axis. So this is 4/1. Now it can be any equivalent fraction of 4/1. So it can be 8/2. It can be 12/3. And you can also use negative values for the numerator and the denominator, because a -4 over -1 is equal to +4. So this is a slope of 4. I'm going to show you what that means in a little bit more detail in a moment, after I draw the line. And a y-intercept means that y is 0, any value less than y equals 0. So when y is 0, it's on this x-axis. So any value less than 0 is going to make the y equal to some number that crosses this y-axis less than 0. So down here somewhere. So a slope of 4 and a y-intercept where the line intersects or intercepts the y-axis at a point less than 0, less than the origin up here. So the first line, and you can draw this line anywhere as long as it has a slope of 4 and intersects the y-axis less than 0. So I start out with -1. So a slope of 4 means that it has a change along the vertical axis of 4 units, 1, 2, 3, 4, and a change along the horizontal axis or the x-axis 1 unit. So 1 goes over 1. So up 4, 1, 2, 3, 4 over 1. Now you can also draw it as, or think of it as a -4, 1, 2, 3, 4, and a -1. -4, 1, 2, 3, 4, and -1. And I also like to look at it as the change in x first. I like drawing that first and saying that for every unit along the x-axis, this would be 4 units along the y-axis. So it's for every x unit of 1. So for every unit of 1, there's a change in 4 units. 1, 2, 3, 4. So 1 unit along the x-axis, 4 units along the y-axis. Now you can slide this line, so translate this line anywhere along this y-axis that you want. And that's going to keep the slope as equal to 4 units. So all these lines will be parallel, but they will just cross the x-axis, or I'm sorry, the y-axis at any value that's less than 0. It has to be anywhere down here. All right, so let's look at the equation. Then is going to be y equals 4x. This is as if this line goes to the origin. This is just the proportional part of the equation. So that would be the line goes through 0, 0 right here. Y equals 0 and x equals 0. But then you have to add a negative value. So any negative value you add is going to translate that line in a negative direction down here. So A is y equals 4x plus negative 1. So y equals 4x. Then you have to add that negative 1 to shift the line down here. B is y equals 4x, so the same slope, plus negative 9. So you're going to shift that line all the way down here. So I'm going to use the rest of these points and show you. It can be any number that's less than 0. It can be either an integer, -1, -2, -3, or a fraction or decimal value. It does not have to always be an integer value. So y equals 4x plus -5 halves. So that's this point right here for C. So 1 is 2 halves, 2 is 4 halves, and then another half is a -5 halves. D is at y equals 4x plus a -10 thirds. So -1 is a -3 thirds, -2 is a -6 thirds, -3 is a -9 thirds, and then one more third is a -10 thirds right there. And then y equals 4x plus a -14 thirds. Well, if this is a -10 thirds, a -11, and -12 thirds is -4. 12 divided by 3 is 4, plus 2 more thirds, 12 thirds, 13 thirds, 14 thirds. So a -14 thirds is going to be right here. So this is -1, -5 halves right here. So remember, 2 is 4 halves, another half is 5 halves. 1 is 3 thirds, 6 thirds, a -9 thirds, and a -10 thirds is right here. -11, -12 thirds, which is a -4, is right here. And then 2 more, -12, -13, -14 thirds is right here. Notice if we want one more third in the negative direction, that would be a -15 thirds or -5. I don't have a line that goes to that. This line actually goes through a -14 thirds. -15 thirds would be pretty hard to see. It'd just be a little bit farther in the negative direction than this line. And then you get down here to -9. So to calculate the slope, that's the difference. So let's label this point right here x. So that point is at 1, +3. So that's 1, 3 for x. And a is at 0, -1. So it's 0, -1 for a. So to calculate the slope, that's the difference in the y values divided by the difference in the x values. So you subtract 3 from -1, so that's -1 minus a +3, and you subtract 1 from 0, so that's 0 minus 1. Now you have to work with these in the same order. So I'm going to say -1 minus 3, -1 minus a +3, and that's also 0 minus 1. 0 minus, and that's a +1 right there. You have to work with them in the same order. So I could say 3 minus -1 and 1 minus 0 if I wanted to, and I'd get the same slope, and that would be okay. Just have to work with them in the same order. So you make that calculation, and -1 minus +3 is the same as how do you get -4? Well, you use the inverse operation, which is addition, and the additive inverse of a +3 is -3. So this is going to be -1 plus -3, which equals -4, and 0 plus -1. So inverse operation, additive inverse is -1. So 0 plus -1 is, in fact, -1. And then negative 4 divided by negative 1 is a positive 4. So the slope, remember, is going from x to a. So it's a negative 4 units. 1, 2, 3, 4, negative 1 unit to get to a. Or you can say for every negative unit in the x direction, negative 1, it's negative 4 units in the y direction, negative 4 that way. So this is how you show that the slope is 4. The slope is 4 from the equation and from the lines, and the y-intercept has to be at a value that's y less than 0. So it has to cross this y-axis at a point that's less than 0, negative.